Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS only, and we have been focusing on ISS 2026. We started the topic sampling techniques, in which we have almost covered all of the syllabus, and we are at the end of it. So in a previous lecture, I explained you about unordered estimators, and one of the method of estimating this unordered estimator is Horvitz-Thompson method. So it is very important with the exam point of view, and I hope I think that we all should focus only on the topics which are important and has been asked frequently in the previous year question papers. So now moving on further, we'll discuss about Horvitz-Thompson estimator, and then we'll be left with the interpenetrating subsampling portion. And after that, we'll be doing some of the numericals or some of the questions which have been asked in the PYQs, and that will conclude our syllabus of sampling techniques, and we'll move forward to another topic. So today's topic is Horvitz Thompson estimator, or this is also known as HT estimator. Anything you can write in exams. They can ask you what is HT estimator, or they can ask you what is Horvitz Thompson estimator. For Horvitz Thompson estimator, define let us define a random variable alpha I for all I goes from 1 to capital N. So the value of alpha I goes like this. Alpha I is, or we can say it is an indicator variable. Alpha I takes two values, either 1 or 0. It takes 1 when the unit is included in the sample. We are writing sample as capital S of size small n, or 0 otherwise. So this is an indicator variable. As we can see, it takes only two values, 1 and 0. 1 when yi, or the unit instead of unit also we can take yi. We have y1, y2 up till yn. So when yi is included in the sample of size n, and when yi is not included in the sample of size n, it is 0. So let us now define, let zi is equals to nyi upon capital N estimation of alpha I for all I goes from 1 to n. So here this is our estimator, which is denoted by zi, and its formula is n small n yi upon capital N estimation of epsilon I, where we can say that epsilon I is greater than 0 for all i's, because if it is equal to 0, estimation can if the estimation is equals to 0, then this will become infinite, which we don't want to get, or which might hinder our process of calculating the estimator. So this is the procedure. Moving on, now what is estimation of epsilon I? Estimation of epsilon I, or alpha I, sorry, I have been pronouncing it wrong, it is alpha I, is 1 into probability that yi belongs to the sample S plus 0 into probability that yi do not belong to the sample S. And let us take this as it has been we obtain as probability of yi included in sample S, because this becomes 0. And let us take this as pi I. Let us suppose it is pi I, where pi I is the probability of including ith unit in the sample S of size small n. This is the probability of including ith unit in the sample of size S, of sample S of size n, and this is known as first inclusion probability. This kind of probability is known as first inclusion probability, or we can write it as inclusion probability of order 1. So this is the concept that we have to know. Now we can define thus the Horvitz Thompson estimator may be defined as, we can denote it by y bar h t. This is Horvitz Thompson estimator, or we can also write it as z bar n. This is also Horvitz Thompson estimator. So z bar n is nothing but 1 upon n summation I goes from 1 to n zi alpha I. So this is our Horvitz Thompson estimator. This has been denoted by this. Okay. Now we have found out what is Horvitz Thompson estimator and all the initial proceedings we have done. Now we will check unbiasedness and then variance and estimation of variance. So first procedure is unbiasedness. For unbiasedness, we will take estimation of y bar ht. So we know that y bar ht is nothing but, we'll write 1 upon n summation I goes from 1 to n by zi alpha I. This was it. So taking out the constant outside, we are left with summation I goes from 1 to n estimation of zi alpha I. Now zi can also be taken out because here we are estimating alpha I only. So it will be 1 upon n summation I goes from 1 to n zi estimation of alpha I. Now we all know that estimation of alpha I that we calculated is this pi I. So instead of this, we can write 1 upon n. Now we can also open the values of zi. Zi was nothing but yi into n upon capital N into estimation of alpha I. We can write directly. And here estimation of alpha I is also in multiplication. So this and this gets cancelled. This and this gets cancelled. And we are left with 1 upon n summation I goes from 1 to n yi. This will be nothing but our population mean, which is capital Y bar. And hence we can say that Horvitz Thompson estimator is an unbiased estimator of population mean. Mean of Horvitz Thompson estimator is an unbiased estimation of population mean, which we had to prove also. And one more thing, that all of these are capital N, not small n. By mistake, I have written this. You can correct it. Okay. Now moving on further to variance. So what is the variance? Variance. So by variance, what do we mean that if we have to find out variance of y bar ht, but instead of y bar ht, I would like to write z bar n. So it can be estimation of z bar n whole square minus estimation of z bar n whole power 2. Now we have to calculate these separately. First of all, we'll calculate estimation of z bar n whole square. So this can be written as estimation of 1 upon n summation I goes from 1 to n zi alpha I whole square. Now 1 upon n square can come outside of estimation, so it will be 1 upon n square estimation of summation I goes from 1 to n zi alpha I whole square. Now opening the square term in the estimation, we will be getting 1 upon n square estimation of, if we open summation zi alpha I goes from 1 to n zi square alpha I square plus summation, double summation will come here, I not equals to j goes from 1 to n zi zj alpha I alpha j. This removes the square. Now we can take in the estimation inside. So we have been discussing estimation of z bar n whole square. So taking the estimation inside, we will get summation I goes from 1 to n zi square estimation of alpha I square, because only alpha I is considered for estimation. Then second one is summation I goes from 1 I not equals to j goes from 1 to n zi zj estimation of alpha I alpha j. So now we'll calculate estimation of alpha I square. We know that estimation of alpha is nothing but 1 into probability that yi belongs to the sample plus 0 into probability that yi do not belong to the sample. So it was nothing but probability of yi belongs to the sample, which we took as pi I. Now calculating estimation of alpha I square, which is nothing but 1 square into probability of yi belongs to the sample plus 0 square into probability of yi do not belong to the sample. So it would be nothing but probability of yi belongs to the sample, which is nothing but again pi I. So we can say that estimation of alpha I is equals to estimation of alpha I square, or how many powers of alpha you can take, estimation will remain same, which is pi I. So replacing the value in the above, an estimation of alpha I alpha j will be nothing but pi. Okay, we'll do this on the next page. And estimation of alpha I alpha j will be nothing but pi ij, which pi ij can be denoted as probability of including ith and jth unit in the sample. S of size small n. This is how pi ij is defined. Now we were calculating estimation of z bar n square, which was nothing but 1 upon n square bracket summation I goes from 1 to n zi square. Now estimation of pi I, your estimation of alpha I square was nothing but pi I plus summation I not equals to j goes from 1 to capital N zi zj into pi ij. So this is our equation number 2, and let us mark this as equation number 1. Now we have to calculate estimation of z bar n whole square. Before that, here this pi ij is also known as second inclusion probability or inclusion probability of having the power 2 of order 2. So this estimation of zn whole square can be written as estimation of zn was 1 upon n summation I goes from 1 to n zi alpha I whole square. So opening the whole, before opening the whole square, let us take estimation inside. So let us take out 1 upon n square outside. So we are left with estimation of summation I goes from 1 to n zi alpha I whole square. Now opening the whole square, we'll be getting 1 upon n square estimation of summation I goes from 1 to n zi square estimation of alpha I whole square plus summation I not equals to j goes from 1 to capital N zi zj estimation of alpha I into estimation of alpha j. Now estimation of alpha I, we know that is nothing but pi I. So replacing the values here, I goes from 1 to n zi square pi I square, because estimation of alpha is pi I and whole square is pi I square, plus summation I not equals to j goes from 1 to capital N zi zj estimation of pi alpha is pi I, estimation of alpha j is pi j. So this becomes our equation number 3. Now from equation 1, 2 and 3, we get variance of z bar n, which is the mean of our Horvitz Thompson estimator, is given by 1 upon n square summation I goes from 1 to n zi pi I plus summation I not equals to j goes from 1 to n zi zj pi ij minus 1 upon n square summation I goes from 1 to n zi pi I square plus summation I not equals to j goes from 1 to n zi zj pi I pi j. So taking the common terms common, we will be left with 1 upon n square taking outside this, and summation I goes from 1 to n zi pi I 1 minus pi I plus summation I not equals to j goes from 1 to n zi zj pi ij minus pi I pi j. So opening zi was nothing but small n into yi upon capital N into a pi I. So opening zi's and zj's, we will be getting summation I goes from 1 to capital N yi upon capital N pi I into pi I 1 minus pi I plus summation I not equals to j goes from 1 to n. Zi was n yi upon capital N. It was zi square here all, so it will also become square upon capital N into pi I into n yj upon capital N into pi j. Pi ij minus pi I pi j. This is the whole term. So here square is given. Okay, we'll take it on the next slide. Variance of z bar n is given by 1 upon n square bracket summation I goes from 1 to n. Zi square was n square yi square upon capital N square. Pi I was 1 in the numerator. It gets cancelled from 1 in the denominator and we'll be left with 1 in the denominator. So it will be 1 minus pi I upon pi I plus summation I not equals to j goes from 1 to capital n square yi yj upon capital N square into pi ij minus pi I pi j upon pi I pi j. So now we can see that this n square gets we can take n square common from here, and here it gets cancelled, and we can directly write the final formula of variance of Horvitz Thompson estimator, which is nothing but 1 upon capital N square. Capital N is here also and here also. We can take it common outside, and summation I goes from 1 to n is capital N yi square 1 minus pi I upon pi I plus summation I not equals to summation j goes from 1 to capital N yi pi ij minus pi j upon pi I pi j. So this is the formula of our variance of Horvitz-Thompson estimator, and it has been asked many times in the examination. It is very important. And the estimator of this variance, estimator of variance of z bar n. We can directly write it as variance of z bar n is an unbiased estimator of variance of z bar n. We can just write the values, exact values here, and then we'll get the estimator of variance of z bar n. So this completes your Horvitz-Thompson estimator, and with this we complete PPS, probability proportional to sampling. Now we'll move forward to, and we have also completed ordered and unordered sampling. Now we'll move forward to interpenetrating subsampling in the next lecture. I hope that whatever we have done in the class have been understood by you all, and if not, then you can ask in the comment box or on the WhatsApp channel, anywhere you want to. Keep on working hard. All the best. Thank you.